All right, welcome to Advanced Analytics in Healthcare SQL, looking at SQL statement basics. Warning, this is not your grandpa's SQL, it's not your dad's SQL. We are going to speed right past how do I do this? How exactly do I type it? And we're going to go the why should I do it? What can I do with SQL? Because the way we did this before was teach you all the syntax, exactly how to type it. How can I write out and learn and memorize every single column name in every table? And that way I can write this by hand and then optimize it afterwards to make sure it's working and use the very limited and difficult to access help documents that might be out there and might not. That is the old world. We don't live there anymore. Today, all you have to do is frame the business question properly to craft a prompt, and AI will draft the first query, often far better than you could. And your real goal is, or your real task, where you start now, is inspecting and testing whether or not it's creating good information how you intended and that you can use it. Then you can iterate and refine, and you're off to the races. So it matters because understanding it still matters to learn SQL, to be honest, because if you can't craft the prompt clearly, you will not get good results. So we're still going to go in detail through the basics of SQL so that you can use it properly as a tool in the way that it is used today. The basic core parts of a SQL statement are clauses, and these are the different types of clauses. There's a select clause, a from clause, where, group by, and join. The select clause is where we specify the columns we want. From clause is telling the statement what table to look in. The where clause is going to filter the results. Only this hospital, only after this date, something like that. Group by is a clause we can use to group the rows when we aggregate. I want the average grouped by the hospital, the average grouped by the month. I want the total count grouped by some other field. Then the join clause is where we connect additional tables based on the matching columns. We're going to look in detail at these things. We're going to start with the select statement. And so what we have going on in the select statement is we are saying I want to retrieve these columns from the data that I have specified. It allows you to specify the exact data you need. As an example, selecting just a couple of items that are important to the question that you're facing. And it also allows you to rename the columns to fit your output preferences. Instead of zip code as the last column that I've selected here, I change that so when it comes out, it will say patient zip code. You see how I've done that there. Next is the from clause. The from clause is where we specify the table that we actually need. So it identifies the table to ask to get those columns. It sets kind of the foundation for this. And not to blow your mind too early, but it is not just a table. You can select from a whole nother query. So there can be queries within queries within queries. So that's where this starts to grow in complexity. There's also an alias here I'll point out that I'm using for organization. I've got the hospital encounter table aliased as ENC, just a short little moniker that I will remember of how to reference that table, and there is where I use it. When I refer to the columns in that table, I can use this so I know it is grabbing the encounter ID, the patient ID, the hospital location, admission, and discharge dates from the encounter table. Next is the join clause, and so this is where we specify another table we want to join to this information and how it should be joined. There are is based on common columns between the two tables. It allows us to do this combination of related data across different tables or sources. As an example, joining the patient data with the encounter data as we are in the above. Now there are four main types to these join clauses. There is the type of join, which we'll go through in detail at a later time. There is the table that you are joining, or not to blow your mind, another query even, that you're going to join onto these results. You can alias that table so it's easier to reference later. And then you have to tell it how do these join together. And the answer for this one is they join on the patient ID. There's a patient ID in the encounter table, and there's one in the patient table, which you can see pretty clearly from this statement. It almost writes like a sentence. It says, join the patient detail table as PAT on this column where it is equal to the encounters table's patient ID column. Next is that where clause where we're going to filter down the results. I only want to see things from this data where the hospital location was the Appleton Community Hospital. So that where clause filters records based on a condition that we set, greater than, less than, equal to, those sorts of things. It enables more targeted queries to refine your results only to what you're trying to ask the data. For instance, filtering patients over a certain age group would provide a little more focused insight based on the question that you have. And that's just a leftover. I shouldn't have that pop up there. Sorry. All right. Now let's look at this more holistically as to what it's doing and what it's accomplishing. We start by looking actually at the foundation of it, which is the from and the join. This is saying I want to grab information from the encounter, the hospital encounter table, joined to the patient details table. That join is happening on the patient ID, which is in common between those two tables. Now, from that hospital encounter table, I want to grab these columns, and from the patient table, I want to grab these columns. Let's go ahead and filter only to where that hospital is equal to Appleton Community Hospital, so that our results will give us some columns from hospital encounter and some columns from patient detail, already pre-filtered only to that one hospital. I didn't mention this very last statement that says limit 5. That is why you only see 5 records here. And so now you can see the result. When I run this query, or when you copy and paste it and run this query, what you're going to get is from that encounter table, the encounter ID, patient ID, hospital location, admit origin, admission date, discharge date, and then from the patient details table, we are getting the patient age and the zip code. Now, you're going to notice if your eye is keen that it does not say patient zip code. I ran these results before I rewrote the query. Sorry for the mismatch there. I'm not exactly demonstrating what I told you it can do. I promise it can do it. Okay, but in reality, how would we write this, okay? How would we get to this result? The truth is we are not going to do it by hand. We are not going to do it the slow way because we are not ancient. We are going to do this in the proper way, which is using the best tool for the job, and that is generative AI. If you work at a forward-looking institution, or what will soon just be the standard, you will have a generative AI built into where you're coding. In this example, Gemini, which I will show you how you enable and start using to write this query next. If you're at an institution that doesn't have this integrated into the place where you would write code, like into Google Cloud Platform, then you're going to have to find a different way to do this while they catch up to you. Be sure to make your case as to why you need it, but in the meantime, you're going to have to be thoughtful here because you want to make sure you are adhering to your company's policy, and those policies have a very good purpose. They're trying to make sure that you don't inadvertently expose any business confidential information, and by all means, never expose patient information. So, this generic prompt example is given if your company doesn't let you have access to a AI that's within your coding platform, then you have to go out and be a little more creative here and figure out how to use ChatGPT or Claude or any of the other AIs in a more generic way. So you see the example of how I change my approach. In the Gemini prompt, I am just being extremely basic. In one sentence, you can accomplish basically the same thing as what I had accomplished before. And in the generic prompt, there's going to be a few more steps, but I'm going to show you those examples, how that kind of flows, and how you will code with those two approaches. So I'm going to jump to that next. Okay, so now let's get realistic. How will you be writing queries into the future? This, my opinion on, has changed in the last couple of weeks. Last couple of months, it's different from that, different from last year. So I'm going to do my best to equip you with the current state, and I might have to update this video next month, next week, whatever the case may be, as I learn. But the world of generative AI is making traditionally writing queries completely obsolete. Anyone who's showing you and telling you, you need to make sure that you know how to do this and type this out directly, know every bit of syntax, is being very inefficient with your time. That absolutely could help, but in a way that you're hitting diminishing returns in your time in a very major way. So Now that we've got the BigQuery environment set up, we've got a billing project, we want to go ahead and enable Google Gemini to be our coding partner here with this. So we have to follow this prompt. You can see where it is supposed to be used here, and you need to come and enable it if you haven't already. So I'm going to go ahead and hit continue here. It's asking what I would like, and so I need to enable Gemini for Google Cloud API and BigQuery Unified API, which is just going to help with something else. I don't know. Error enabling billing account. Okay, so I don't have a billing account for this, so it's not going to let me, but Gemini for Google Cloud API looks like it's going to let me. Permission, Gemini for Google Cloud users, grant permission to use Gemini BigQuery, list, separated users, or the group. You don't have to list anybody here. It's just you in this working environment, so you're good to go. Now that this is here, Gemini SQL query, auto-generate, SQL generation tool, explanation, code completion. So we want code completion because that's going to help us when we're getting started. And there we go. So the example we just looked at together in the presentation is to select from the hospital encounter and patient detail some information. Okay, now let's talk about how would this actually happen in the real world, because I'm going to be real with you, not just show you the old way and teach you like a professor, because we are here to be practical. I'm trying to get you as fast as possible to value. And so the truth is, this is changing. I look different at this week than I did last, and different from the previous month, and for sure from last year. No one is going to be writing SQL in the near future. You absolutely need to understand it in order to be able to use it, but you won't be actually writing it. When I got started, it was long sessions of typing out each part, going and searching and finding all the column names, and doing that kind of a work. But that is not what we're going to be doing anymore. We have generative AI that really helps supercharge this ability and helps us just get to more difficult questions. Some people might think, oh, you're glossing over learning. You're actually not learning deep. I completely disagree. We are glossing over the simple stuff, the routine stuff, the super rule-based stuff, so that we can focus on actually thinking. That's what this job is going to entail. If you want to be rule-based and just focus on syntax and every little detail in how to write these things, your job is about to be removed completely by generative AI. So make sure that you are a user of these tools, not that someone else that is using them is going to pass you by. So I'm going to show you how to do this with Gemini here. Let's also go look at ChatGPT, because let's say you are at an institution that has Google BigQuery, and so you're following me up to now. You're like, awesome, I've got someone who's going to show me a little bit about how to use it. And then you get to Google BigQuery in your institution, and they won't let you use Gemini. That would be so frustrating. I'm sorry. I'm sure they will catch up eventually. But there's all sorts of free versions of these tools that are available to anybody. And as long as you're not inputting any protected health information or business confidential information, it is completely reasonable to be using this as a tool. And you absolutely should be. I think you should be thinking of it as a complete requirement for an analyst position in healthcare, is to be an intelligent user of generative AI. So let's first look at Gemini. You see that I'm just using this link here, Generative SQL with Gemini. And I'm going to go ahead and say select. No, sorry, not select. I'm going to write this in natural language. I want to gather details from the, I'm going to leave that misspelled actually. Let's see how it does. From the hospital encounter table, and join to it patient detail, and return all patient details. Here we're going to get a pretty open query. I'm sure it's going to gather just all of the columns, and so we might want to tune that in, and we might not, but we'll kind of see. Okay, great. So look, it's got a select everything from TO, which is what it is calling hospital encounter, and then go ahead and get everything from patient details. So I like how it named patient detail, but I don't like how it named hospital encounter. You might suggest to it to alias patient encounter different. So alias the hospital encounter, patient encounter, sorry, hospital encounter as ENC. Let's see how it adjusts our code. Okay, so it's going to change that to ENC because it is aliasing it different. I'm sorry, this window won't get much better, but I'm going to go ahead and say that's good. That's where we're going to grab everything from those two. The only thing we don't have done yet in our query that was in the original is that we don't have that hospital location filtered down to just the Appleton Community Hospital. And so we may insert that ourselves. We may also go ahead and say this. I want to filter these results to where the hospital is. That hospital I pasted in there, the Appleton, whatever the case may be. And it didn't quite get it. So, oh no, it did. Yep, that's it. So I don't love what it's doing here. It is giving me a totally different query. So I think let's try something else. Let's go ahead and discard that and go ahead and get everything. I want to transform this and say I want to filter these results to only where the hospital is Appleton Community Hospital. Let's see what it does for us. Okay, so it keeps this. Everything else is the same, except it's got where the community hospital is, that Appleton Community Hospital. So we say insert, and now we've got the exact same query that I had written for you earlier for the example, but I haven't written one piece of this. I've just been asking a natural question of Google Gemini. So let's go ahead and do something similar, but let's go out to ChatGPT. I'm showing you this because you may work in an institution that doesn't allow access to these tools, generative AI tools in the coding environment. And so you're going to have to be a little creative. It is appropriate for you to go ahead and take advantage of any of the these types of things, as long as it's within your institution's policy. And typically what that policy is outlining is that you can never use any even remotely patient-related data, and you cannot use any business confidential information whatsoever. So what are we going to have to do? We're going to have to get a little bit creative here. And so I'm going to show you the type of prompt that I'd be writing to do this. I'm going to say, I'm going to have to describe my data a little bit further before I can get there. And I'm going to have to use some placeholders and replace some information. So we go ahead and say, I am writing a query in Google BigQuery on my data set that has a table on hospital encounter information and one that has patient details. I want to return the columns from each. They are connected by the patient ID. Help me write this code. Actually, let's get patient ID spelled exactly like it is in the data. Okay, so it's actually gone pretty far and given me a number of things. So it's collecting some patient items from the encounter table, or sorry, some items from the encounter table, some items from the patient table, and it's gone ahead and put some pseudocode in here, like from my project dot prod dot encounters. So this is pretty much ready to go, with the exception that I need to put in meaningful things. So I can go ahead and bring this over to my BigQuery environment, start a new query. I'm going to paste this and I'll show you what we can do. Instead of what they have here, what we can do is go ahead and get started. We know this is hospital encounter. and see as I start typing how it auto completes, or it gives me an option for what table I might mean. So I tab forward and I've actually got that table there as I need it. So you see how fast that was to replace this. And so now we're going to go ahead and get patient detail. I paused for a second just to let it give me those options so I can tab forward. And now I've got that completely in there. Now, it turns out it grabbed a couple of columns that are actually real, and there are some that are not. So we've got encounter CSN here that is not actually a column in our data set, and so we have to figure out what that column is. And as I start typing encounter, I see the option. It is actually encounter ID. Length of stay, I don't know if we've got length of stay in there yet, but what I can do is do E period, and it's not catching up to me. It's not giving me the auto prompt, but that's okay. What I can do is go back to this table and figure out what are the columns that I want. So I personally would usually be coming to do something like this. Give me encounter ID, hospital location, admit origin, DRG, and then I can copy these and bring them over to my query over here that we were working on prior, and put these in instead of the ones that were given by that environment. Sorry, I just need a comma. So now we've got select encounter ID, admit origin, and DRG. I might put that E in front of these in order to prefix them properly and just make sure I'm staying organized. It turns out it's not completely necessary because these column names don't exist in the patient detail table anyway, and so it understands that. The patient stuff, I would go ahead and come over to my patient table and do something similar. So I would grab the patient detail, and I've got the schema here, and I'm going to say, I'm going to want patient age and zip code, and that's kind of it. And so that shows up over here. Now I've got the column names and how they're spelled. Back to my query. Paste them here, and what I'm doing, sorry, moving a little fast, is this is going to be p.patient age. It's coming from that patient table prefixed with a p. And I'm just getting stuff aligned, so it's a little easier to read. And p.zip code. Okay, so that is the path that I can take to get to what I need. Now, we're at something really similar in a couple of minutes with this. Of course, you could write this, and I'll just show you a little bit about what that would look like. And as you get more familiar and comfortable in here, you may decide to start doing this. You may just start typing select star or select everything from patient or from hospital encounter. Let it find that, select everything from hospital encounter, and let's just verify we're kind of getting what we need there. Great, okay, and then we would say, all right, you know what, I'm really only looking for that encounter ID. Let me get hospital location. And admission date. And discharge date. Say that's really what I was trying to focus in on from the encounter. And so now you see here, select these columns from the hospital encounter, and we've got a working query just in the sort of first part. What do I want to everything coming from for that first table? So let's go ahead and get this alias so that it starts working very similar to what we were doing before. I'm going to get that E in front of it. So I keep myself organized. That's really the only reason I'm doing this for right now. Now let's go ahead and figure out our join. I'm going to start with the left join to that patient detail. Pause for a second for it to find the table. Call that P. We're going to have to tell it what is it join on. Okay, so P dot patient ID is equal to E dot patient ID. So you can see as I just start typing, I'm getting autocorrects, auto completions. I'm getting all this stuff that helps me navigate this world very simply, to be honest. And so I'm going to do, again, P dot and pause there, and it gives me the auto completion of what's in that table that's aliased as P. Patient age is there, P dot, patient zip code is there. And so you see how really, in a simple query like this, we are getting with a really similar amount of time from 3 different methods to the answer. And we're using the tools that are at our hands and what we're comfortable with. We're using the autocomplete, we are using Gemini, or we're going out and using another generative AI model in which we can get what we need in order to get to this. Now, there's a couple other things that become really helpful, though, about using the 2 methods like Gemini and ChatGPT. So let me show you those. You noticed earlier when we selected everything and we went to transform that query, there was another option that says explain this query. That is a phenomenal tool for beginners that I absolutely did not have, and is going to just supercharge your learning. It's going to take you to a near mastery level or capability if you give it a little bit of time. And you can get a full query or a full answer of what this is doing, and you can keep asking it questions. All those little questions that come up during learning that you usually have to ask a professor, I almost can't think of good examples in the learning process of SQL that you would or should go to a professor on. If you ask me a question about what this query is doing, it will take me quite a while to look and think through it, and I might not even find the issue that's happening. But generative AI is going to get you there usually quicker. It's just how good of a question asker are you? You need to get very good at giving it the details it needs to be able to answer your question. You need to form your question properly, which is true for humans too. But that is the case there. You can see that when I did this in ChatGPT, it actually started by giving me some of those things. It even gave me some implementation. I'll just give you a hint as a learner. This is a process I usually take with a new technology I'm using ChatGPT to accomplish. I'll say something like, I am a total beginner. Please guide me step by step on how to do this. Go slow. And so now it's going to go ahead and break that down into tiny little pieces. And so it even goes as far as get into BigQuery. Go to your Google Cloud Console. It's giving you links, the kind of stuff that I would typically have to put in my presentation and send out as a link, and watch even a few people still not be able to accomplish that. It will give you the link. It tells you how to get there. If you get stuck on any tiny step, like on the left-hand sidebar, you can't see it, type that question in. I can't see the left-hand sidebar, or I only see these things. I don't see what you're telling me. The days of I'm stuck, I'm going to have to ask somebody are just about gone, especially in this kind of a thing. And you have a step-by-step tutor that is going to help you do everything that you need to. It is just how much time, patience, and intelligence do you have. The other, let's just pause there. Okay, so now you can go from how does it look, what does it mean, what is the structure, and how do we put it together, directly to running queries, directly to I can accomplish this, and you have a little tutor that is always with you. So that is what I wanted to show you on how this will actually happen in the real world going forward, and why you absolutely need to be learning SQL and don't need to be learning SQL. You need to be learning it because you will have tools like this that will help you use it, but you don't need to learn it in the traditional way. You don't need to learn every syntax detail and exactly how to do this. You have a step-by-step tutor that will show you everything and do most of that writing for you. So the focus should be on what is the meaning of the different parts of a query, and being able to describe it in natural language so that one of these tools can help you get there. Okay, now you're seeing how we're writing code, how this process actually goes, and it's much more approachable than hopefully you thought from the get-go. But I have three more quick tools to kind of share and show you here. The first is an order by clause. So it's just another item that can be in our SQL statement, and its purpose is just to sort the results. So it's pretty simple. What I'm doing here in this example is looking at the location details table, grabbing the hospital name and the number of beds, but then ordering them by the most to the least by using that DESC for descend, or I could use ASC for ascend, where it would go the opposite direction. It's just sorting that result that I get. That's all that it is doing. The next thing that we do is aggregate. So this is aggregate functions in the statement. So this isn't a separate clause. This is just showing you that there are functions you can use to do analytical things called analytical functions. And they are most of the basic math things you would imagine: count, average, minimum, maximum, those sorts of things are all available here for you to do on the tables of information that you have. So you might want to count the total number of patients, in which it's going to look at all of the records there and just tell you how many there are. I call it total patients because I'm grabbing it from the patient detail table, where I know there is one record per patient. Next, you see that I grab the average of the patient age column in this way. We use AVG, which is the function name, and then we put in there the column that we want to take the average of. And so this is going to return for us the result. So this is another area where, guess what? Gemini is going to just help us do it, help us get over those barriers, help us figure out what is the name of the function, how do I get it in there, how do I do it on this column. You don't have to ask me anymore. You don't have to wait until you get to a professor. You don't have to wait and scroll through a ton of documentation to try to figure it out. Gemini is just going to do it for you. So let's hop out and actually see what that looks like in the real world. And I actually want to jump over to this one. So I'm in Google. I am in our data set here, and I'm just asking, hey, Gemini, I want to know the total patients and the average age from the patient detail table, and let's see what it does. Select count as total patients, AVG patient, age as average. That is exactly what I had written for you as an example, and now it is done for you. That is what that looks like. This is what this process is like nowadays, which is actually just super, super exciting. So, okay, let's hop back here and talk about one last thing, which is the group by clause. The group by clause is where we're going to go ahead and tell the table, when it's doing their aggregate function, how to group and do that function. So here you're seeing an example where I wanted to do that count in the hospital encounter table, but do it by hospital. And so I select the hospital location and a count of that encounter ID, but I group it by the hospital location. So here is where I don't want to count all the IDs on their own. I want to count it for how many have each of these hospital locations. And you can see the result down below, which is by each location, what is the count. So that's an extra sort of complication, and this is where some of the complication of writing SQL grows, but you can see the actual common sense thing that's happening is still very simple and very simple to express in language. Tell me the total patients by hospital location. That is what's actually happening here, but the how you do it specifically in writing out the SQL is where we lose the thread of like, oh wait, how exactly do I do this? What are the rules? All that stuff is melting away. Being able to ask the question is actually the important thing. Being able to think is the actual important thing that's happening. So one natural conclusion you might be reaching is, oh my gosh, I've got to write this stuff for every calculation I do in analytics. This is going to be forever. I'm going to just be sitting typing at a computer. The truth is, no. This is a great tool to gather and combine data so that you can do the calculation in a better tool. Okay, so I want to show you what that's like, because if you are a SQL only person, this will be your life. Analytical question, write SQL, slight variation on that question, rewrite SQL, rinse and repeat over and over and over until the end of time. If you're a little bit smarter, your life will look like this. Analytical question, drag and drop dimension and measure, Slight variation in the question, change out the dimension, and rinse and repeat through actually getting information quickly between question and information. So let me just show you a little bit of what that looks like between these different tools. I want you to understand what I mean and why I'm saying that. So I'm going to jump over here to our example group by query, where I'm saying I want to see how many patients there are by, or how many encounters there are for each hospital location. It looks like it's pretty evenly distributed. Cool. And in fact, now there's even this cool thing here in Google BigQuery where you can go to a chart. Sweet. Now I've got a chart of it. I've already gotten to a visualization. Awesome. Now my next question is, wait, I need to see this a little bit differently. I don't want it just by the hospital. I also need to see it by the hospital and the month that it is in. And so guess what? I just asked Gemini. I went ahead and said, select all of that, and I need to transform it. I also want to group by month of discharge. And guess what? Gemini instantly knows what I'm trying to do and accomplishes it for me. That is how I got to this result. And so now it is grouped by the hospital in the month. So you see that Lakeside Regional in May of 2024 had 22 encounters. And in December of 2024, that same hospital had 29 encounters. So you might think, oh, okay, well, that's not that long, Jesse. Why are you making me try to go to another tool? Because that is poorly formatted, hard to really see. As you saw, it's like, wait, that's May and then December. Oh, I'm going to have to order this. You'll have to go rewrite. You'll be in that loop forever. It's obnoxious. But you might say, oh, I can just pull it out to a chart. I mean, kind of, and maybe this will continue to get better. But what that's going to mean here, first of all, you're going to another tool already. They're basically using Looker Studio or Looker, Google's Looker here to just do this for you, which you don't realize in the background. But you're kind of stuck. It's just got that one dimension, either hospital or discharge month, and you can't do both. You can't recombine them. You can't try them. Maybe you can try them as different charts. I don't know. But this is what we, oh, you can, look at that. I'm sort of proven wrong. Doesn't this look nice for you? Anyway, this is not the tool and the place to be doing this. You should be doing this in Tableau. So let me just pull you over to Tableau Public to see what this would look like day to day as you build out your skill set and you're able to pull data from a database in BigQuery and use it in a tool, an effective visualization and exploration tool like Tableau, Power BI, some of these things. Okay, so let's look at what this should be in Tableau, a more efficient tool for the exploration process. So I've gone ahead and built the average length of stay function here. You'll see that kind of stuff in our Tableau work, and you can find it online if you really wanted to. But I've now got the average length of stay by the hospital location. So your analytical question now changes, and you say, I need a slight variation on that. Instead of rewriting, you can just exchange the dimensions, add and combine the dimensions, try different visualizations, all sorts of items. So as an example, the next level of question might be, hold on, I'm interested in what this looks like based on the patient class and the hospital location. So I bring patient class over, and now I can see average length of stay by hospital, by patient class. Or if you wanted to compare how the different patient classes look across the hospitals, just switch the order. And now we've got for all of the observation patient classes, what is the average length of stay at the different hospitals, and we immediately can pick out little patterns and things like this. Look, Morgan County Medical Center has much better length of stay for their observation patients than everybody else. So this tool is so much more capable because it allows you to start mixing and matching, changing how you're asking that question of this measure, length of stay, and in a visual format natively, instead of rewriting a query every time and the result being a table. So this is the way that it should actually happen in an efficient tool that helps you explore instead of always constantly writing SQL. Okay, Let's go back to our slideshow. Hopefully I made my point there. Next, I want to show you how to explore the tables in our data set. I mentioned the sort of overall structure and what's there, but it's helpful to get eyes on it. And so I've got this example here for you, which you probably could get to with Gemini, but I don't think it would quite do this because I'm doing something a little unorthodox. But what I'm saying is I've actually written 6 different statements and put them into one query, and I'm going to show you how they come out. I'm saying select everything from the patient detail table, and then I use that semicolon or whatever that's called to end that statement. And then I write another statement and another statement. And when I hit run on this, it does all of those, and it allows me to toggle back and forth between these results. So this is a quick way to go ahead and look at all the tables in our data set. So let me bring you back here to BigQuery and where I've already got that done. And when I run this, you're going to see it'll take a second, and then it will have all 5 of those results sitting here in the results area, where I can view the results of the first one, which is clinic encounter, and I can get a preview of what this is. All right, we've got an encounter ID, patient ID. Looks like there's a visit type, the visit provider's specialty, appointment time, room time, and checkout time. Great. There's some cool timestamps that might be useful here when I have clinical questions in the ambulatory setting. So I use this back arrow here to jump back and view the next one, which is the ED encounter, to see what is different about the ED encounter. I've got encounter and patient ID again. Great. That's going to help me connect information. Timestamps, it looks like I've got the arrival time, the room's time, and the disposition time. As well as transferred to the floor. And look, not everybody gets transferred to the floor. That's interesting. I also have a few other pieces of information. So this is a very quick way that you can go ahead and look at all of the tables in our data set. Now let's go ahead and think back to where we are at. We are exploring the data set, and this is the actual structure of that data set. There are 4 encounter tables that give you summaries about what happened for a patient when they were in the hospital setting, ED, OR, or clinical, with, as you saw, slightly different details that are relevant to that setting and that visit. And then there are 2 detailed tables that you can jump to gather more information about the patient and connect it to your encounter, or you can grab something about the location. That is actually the hospital location detail that we have there. Okay, so I hope you are seeing my point that this is no longer the traditional world of learning SQL, which should be exciting for you. It means a lot less boring, mundane work in order to get to the value. And the value is created by you having the ability to understand what SQL is trying to do, which is just pull information from tables, combine it, and create data, and allow you to inspect and see, did you get the right information? Because if you did, you can take it to Tableau and start exploring. So that is the new world of learning SQL. It is different than I thought about this a couple of weeks ago, very different than I thought about it a year ago, extremely different than how I learned SQL. But I want to make sure I am being efficient with your time to pick up this skill set and go as fast as you can away from typing to thinking, away from the how do I do this again to the why should I be doing this? How do I help solve problems? That is the intent here. And that's why we try to pick up the best tool in the toolbox in order to do that. Okay, thanks for sticking with me in this part of the series. Let's continue to learn SQL and become an effective analyst in healthcare.